Hi, this is Will from .text. Today, we're going to take a look at a very simple, straightforward example of how we can use outlines and structured generation to solve a very real-world task, which is going to be building a zero-shot classifier so that we can classify complaints. We'll dive a little bit more into what the problem is, and then we'll see how we can solve this actually quite simply with outlines. So the task we have is we have a whole collection of consumer complaints. Just imagine we're an e-commerce website and we have complaints coming in. One of the things we want to do is dispatch these complaints to the correct department. It's actually a pretty reasonable workflow you can imagine where you'd want to start up a funnel for handling user things, and the first step in user complaint processing is to figure out who is responsible for this and how we can get them involved. So pretty realistic scenario. The data is synthetic, but the use case is not. I think this is a very common sort of use case for things is sort of customer complaints processing or customer support scenarios. This is something we see LLMs use for a lot. So in this case, we have 4 complaints in our data set, 4 departments in our data set: clothing, electronics, kitchen, and automotive. And we would just like to classify which department each complaint belongs to. Here's some example of what the data looks like. As you can see, the complaints are just sort of people talking about a product. In this first case, we have a knife set. We know that that should belong to the kitchen department. What we want is to have that figured out for us. And in none of the cases do the complaints actually mention in the department name. They just mention a product. So we need a model that's smart enough to figure out which department that product probably belongs to. The solution we have, of course, is a zero-shot classifier. If you're unfamiliar, a zero-shot classifier is just a classifier that requires no examples for us to start working with it and start using it. This is really cool because if you've worked in ML before, you probably recognize that there's a big issue with sort of these small data sets. I've worked on many similar problems to this in my life where you have a small collection of unlabeled data, you're trying to build a classifier, and it's just very hard using traditional NLP techniques. Thankfully, LLMs, even and especially local open LLMs, are capable of doing quite well on this task, as we'll see as we walk through this notebook. Of course, one of the problems with LLMs is they yap a lot. We just want the names of the departments. We don't want to have extra work created for ourselves. To help us solve this, we're going to use outlines and structure generation. We're going to make use of a very, very simple outlines tool, which is generate.choice, which allows us to constrain the output of the model to being a specific number of choices that we have defined. Let's start and jump into the notebook now and start figuring out how we can use outlines, get a sense of how we can use outlines to load models, how to use unstructured generation with outlines, and then finally, how to solve our problem using outlines. Okay, so let's take a look at what we have here. We have some imports, which are pretty standard. We're going to import JSON so we can read the files that are written in JSON. And we're going to import outlines, which will be actually doing most of the working with the models for us. We don't have to load all of our models separately. We are going to be using Torch, but only because we want to use sort of the Torch data type. It's not going to be used very heavily. I am importing the Transformers auto tokenizer because I find it's a great way to automate building instruct prompts for your models. Every open LLM that does instruct format of prompting, sort of chat format prompting, they tend to have slightly different interfaces to do that, slightly different ways to do that prompt, and the auto tokenizer has a method that will help us do that automatically. And then of course text wrap dedent is just so that we can structure our prompts and not have to worry about having weird white spacing issues. So if you look at this example, I actually use outlines all the time, even when I'm not doing structured generation, because I really, really like the interface to working with libraries like Transformers or Llama CPP. It's all in one place, and it's sort of, I think, an underrated feature of outlines is that it's actually very easy to work with. So as you can see, we have a model name. We have some configuration details right here. I'm on a Mac, so I'm going to use MPS as my device type. If you're doing this on a PC or a Linux box, you might want to use CUDA. And so I add some configuration details, and I also define my tokenizer here. But this is all outlines doing this work, and it's very straightforward, very clean, and I actually really prefer this interface to the other ones, especially since I can easily change between Transformers or Llama CPP as I please. So we've loaded this tokenizer, and then we're going to load our data. And as I mentioned before, it's sort of these complaint data sets. So we have a couple other things in the data. We know the true department. When this data was generated, we made sure we kept track of which real department it was so we can kind of assess how well our model is doing. And we also have an order number, which is another exercise we'll do later where we actually figure out how to correctly parse out order numbers that follow a specific format. Here we have our departments, which is the clothing, electronics, kitchen, automotive. We're going to be using this later when we actually want to do structured generation, and we're also actually going to manually put this in our prompt. But we could have this in our prompt automatically as well. So we're going to create our prompt. It's a very straightforward sort of LLM prompt. We tell it we're going to provide it with a complaint to analyze. We're going to provide the different departments it could belong to. We are going to specify to the model to only answer with the name of the department. If you've worked with LLMs before, you probably know that this is always an issue. It always does more than you want, and you keep saying things like, please, please don't do that, or I only want JSON, I don't want any markdown format. This is sort of a classic example of when you should start using structured generation. So we go ahead, we have all of this, and then we pass in the complaint finally. We can sort of see what the realized example looks like. And again, I think some of these parts are actually not necessary for the Phi3 prompting structure, which is great because this apply chat template automatically handles that. But you can see the user complaint starts with a specific tag. Again, this tends to be specific towards the model, and you don't have to think about that if you're using apply chat template. So that's why we're using that there. I do want to point out, you can always do unstructured generation with .text, with outlines, and I always do it, and you use the .text method on outlines in order to do that. So we just pass in the model we want, and we have this little text generator now. We're going to go ahead and generate 4 example complaints to kind of show why we need structured generation at all. This formatting is kind of like quick and dirty, but you get the idea. The LLM outputs this part, and then the actual value is here at the end. So you can see right away, it gets the answer right, which is cool, automotive, that's great, except it keeps yapping, it keeps talking. We don't really want that, right? Even though we said keep it limited, we don't want this. This one never actually gets to the point of the department it wants. And this one starts with clothing and continues on rambling. So you could imagine, and it does, if you look at the cases, it's actually getting the ones that answers right, which is good. So this is without structured generation. The model's performing reasonably well. But if we're trying to build a larger system with this, where this is step 1 and we want to feed it into another automated process, maybe there's a way we generate emails for each department, and each department has a custom email address we want to send it to and a custom template for that. If we're trying to build a system like that, we don't want to have this kind of output. We really want structured output. You could solve this by sort of defining some regexes or looking for the department names in the output, but it's not really what you want, and we don't want to have to add that extra level of sort of processing to this code. The whole point of using LLMs and AI is things are supposed to be easier for us, not more complicated. So we're going to go see how we can use structured generation. We're just going to use outlines generate.choice instead of outlines generate.text, which we saw is what we had before. And it's really, this is it. Like, I think one of the things I love about outlines is just not a lot of steps to get your structure in place. We loaded the model, and we really have to add arguably not even one extra step, right? We need to have this generator if we want to generate text. We're going to create a structured generator using outlines generate.choice, and we're just passing in the model and the departments, and that is actually it. We have this very simple loop here, which will go through all the examples and print out the same as we had before. Again, it's a bit crude. It could be a prettier interface, but the whole point is just to sort of analyze how well our model is doing in practice. And you can see it actually does quite well. And most importantly, every single output is the structure we want it to be. It is the definition of a complaint department. We are running through and keeping track of the sort of performance here, and we get a 92% accuracy at the end of the day, which is pretty awesome for a model that is running on my desktop right now. It's Phi3 medium instruct. This ran relatively quickly, and it's an open model. So for an open model that has no examples, we're able to get 92. Sometimes I get 94%, depending on sort of how lucky we get with the outputs. But between 92 and 94% accuracy right out of the box on labeling, which I think for many tasks is a reasonably acceptable rate of accuracy. I've certainly built plenty of other NLP-based classification task type things in the past where the results aren't that good. In an automated system, if we can get these right about 90% of the time, we can probably reduce the amount of work we have to do. So that's it. That's sort of the basic overview of how to use, I think, what is the simplest outlines feature. There'll be other content coming out in the future where we talk more about slightly more complex examples of how to use outlines and then move eventually into more advanced topics. I hope you found this useful. There's links in the bottom to repos where you can get the code for this, as well as the outlines library itself, and sort of other useful links that you might need. I hope you enjoyed this, and stay tuned for more content coming soon.